Hi everyone. Healthcare is facing significant challenges today. 50% of the global population lacks access to essential health services. Overcrowded healthcare systems, delayed diagnosis, and poor quality care lead to millions of preventable deaths annually. CareConnect is a solution that brings healthcare closer to the patient and the doctor. This bot speeds up diagnosis, enhances decision making, and reduces the workload on the medical professionals by automating the common queries. It helps doctors save 40% more time for patient care and reduces hospital readmissions by 30%. So let me break down the architecture of the how CareConnect works. First, we set up a SnowFlake environment where we store the medical data. We created a database and the staging area where we uploaded the medical documents. And later on, using the LangChain, we processed each uploaded medical document and converted it into the chunks of text. And the chunked data was then stored in the Snowflake table. We utilized the Cortex search to enable low latency, high quality hybrid search on the chunked data in the Snowflake. This setup allowed us to power the RAG workflows, ensuring precise and contextualized responses. Unlike vector only search solutions like Pinecone, Cortex Search leveraged both embedding similarity scores and keyword relevance to enhance search accuracy and the user experience. On the front end, we used this Streamlit to build a user-friendly interface where users could upload the prescriptions and ask health-related questions. When a user when a user uploads a prescription or asks a question, we extracted the relevant text from the prescription and then fed into the system. The system looked for the relevant information within the chunk data stored in the Snowflake and retrieved the most accurate matches. So this combined information is then passed to the Mistral AI model to generate an accurate and context-aware response. So this is the worksheet in the Snowflake. Here we have created the database schema and the text chunker function and the stage where we have uploaded the documents, where I can show you the documents over here. So these are the documents. And created a procedure to process the uploaded file. And this is the Cortex search service function. So this is the chunked data stored in the docs chunks table. And this table consists of the relative path, the size, the file URL, and the scoped file URL, and the chunked part of each document. So this is the code where we have used it. So, the main application starts from here. This is the Streamlit based main app handling the UI, file uploads, and the chat interactions. And the next one is the connection file. This establishes and manages the connections to the Snowflake. And the next one is the conversation handler. It tracks and manages chat history and context. And this is the Cortex completion file. It generates the responses using the Cortex completion search in the Snowflake. And the next one is the upload prescription. It processes and extracts the text from the uploaded prescription files.
Hello everyone, welcome to the demo of the application CareConnect. So if you open the link, you will get this kind of interface where you can just select which LLM model you need to choose. Here I've used the Mistral Large 2, and here you can also select whether to show the source document from where the information is being extracted. So before that, I wanted to show you that we have used these many PDFs in our knowledge base, like for example related to the fatty liver disease or some diabetes or various other blood pressure related control and all. So what we'll do, we'll just ask a simple query like what is normal range of diabetes. So what's the normal range of diabetes? Symptoms that give okay, it has given answer pretty well, and also our system has referred to the PDF where this information is being present. Let us consider a scenario where the person might have some lab report, or he wants to understand what disease he have. In lab reports, there are various complex terms which he might not understand. So for demo, I have used this lab report. This lab report, you can see we have our dummy patient have a fatty liver disease. So what we'll do, we'll browse and we'll upload very same PDF which I've shown you, and the system will extract all the information from the PDF. And this is my lab report. Tell me what disease I have. Okay, we'll just enter and then it will analyze the lab report and it will just say, okay, what disease you have. You have just asked the disease and it has said you have non-FLD fatty liver disease. The answer is pretty good. Now let us ask that, can you explain me this in simpler term? Term. So make sure the point to be noted here is that this represent a disease, right? This represent a disease. I have nowhere mentioned in this query, in this particular query, I have nowhere mentioned which disease I'm talking about. So this app also stores the history of this session. So whenever the user query about a disease, it will add that to the historic conversation part, and it will fetch that whether the disease is pointed out, the disease which user have asked earlier. So it maintains the history of the conversation. So it has given very right answer. Also note here that since I have not selected to show the source document, it has not shown over here. So this is all about. Thank you very much for listening.
As you have seen the demo, let's focus on the challenges faced. We have faced challenges with efficiently processing the large files and optimizing similarity searches for quick responses. And during deployment, also we have faced a few issues related to the versioning. And then later on, we will be working on adding multilingual support for global access, incorporating voice inputs, and expanding the medical knowledge database to enhance the system's effectiveness. Thank you.